did this, you answered those questions. The first one was definitely linear. You had to use your equation, take a look at it. This one depended on the numbers that you used, but I agree, you kind of, when you looked at your graph, had something that maybe curved like this, depending on your scale. Some of you, depending on the numbers that you used here, maybe yours came almost like this with it. Like, it depended on the numbers you used. So none of those would be wrong as long as I can see your numbers in your table. The same thing will be as we get ready for our test. Please turn to the I. We're on page 18, is it? I want you at the bottom of page 18 to write in these numbers right now. For 4, the average data we found for the break was 42. So when it was 4 inches long, it was 42 pennies. 6 was 26, 8 was 19, 9 was 16, and 11 was 14. And the first thing I want you to just look at that data, and then we are going to make, as you look at yours, you're going to put breaking weight on the side. That's going to be our pennies. You're going to put length on the bottom. And anytime you're looking at a table, I don't know why, but some of you switch these two around. The first thing is always your X. That goes on the bottom down here. Some of you keep switching those and you put the breaking weight down here. This is your X. This is the length. That was in inches. Then put your breaking weight. That's your pennies. Right? That's our dollars that we were talking about. In this case, pennies that we were looking at. And now I want you to plot those points. So at 4, go up to 42 and put a point. At 6, go to 26. At 8, go to 19. 9, go to 16. 11, go to 14. Looking at your graph, what were you guys thinking? Linear or non-linear? Definitely kind of non-linear again, right? So if I set my scale, so does the data look linear in the table? You would probably say no. Why would it be a no that my data in the table up here doesn't look linear? Are we subtracting the same thing every time? No. So why does the data look linear? We said no. Why? The reason it does not is there is not constant addition. And we might say in this case, there is not constant subtraction, right? Because they are subtracting. I mean, I can see that from 26 to get to 19, I subtracted 7. But then I go from 19 to 16, that's a subtraction of 3. Then I go from 16 to 14, that's a subtraction of 2. So I can definitely see that it is not the same. So would it be a line or a curve? We would say it's going to be a curve. And then if you draw that. So if I am looking at drawing that curve, you are just going to take your point. And it's not going to be a straight line. And we think it's going to maybe continue. And we are looking, if you want to staple that first, but then I can staple it. Perfect. Do you have your workbook today? Yeah, that'd be great. Right up there. Yeah. All right. So as we look at that next page, as we are looking at this. So you look at the curve that we drew on our graph. It says use the curve to make a prediction. What do you think the breaking weight for 10-inch bridge? Okay, so you look at this and you think, oh, sorry about that. And we think that we are looking at a 10-inch bridge. So if we are looking at that and we go down, what do you think at 10? So if I have 10, it's kind of in the middle here, and depending on your curve, mine was probably a little less. It looks like maybe we should have, if we look at 10, about 15 if we're looking at that, right? So about 15 pennies is what we want to say it should break. As you take a look at that next one, what do you think for what do you think? Make a prediction right now and tell someone next to you, what do you think for 32 pennies? You're going to go across from 32. God. About how many? If we are looking, hopefully it makes sense that you're thinking maybe 5-inch bridge, right? If you're looking at that where you had 32. And again, if you're not sure, you're going to go across from, I think 32 is about right here, right? And then you go down, and as we go down looking at that, we would say about 5 inches. So when it's not linear, or when it's unlinear, you're going to use the graph more or that table to make some predictions. You are not going to want to have an equation because the equation is a lot tougher. But it says here is, if we use a graphing calculator or what's called the Desmos calculator, and if we are looking at an equation and they say we could come up with this equation, y equals, this is exponential that you're going to learn about next year, 75 times 0.85x. So if we want to find the breaking for a 16-inch bridge, that is when x equals 16. If I give you the equation, what I'm going to ask for you to do is we're going to take out those calculators of yours. Y equals 75 times 0.85. You're going to use the caret key on your calculator, and then you're going to plug in 16. And we are going to take a look at that. So if I am looking at that, making sure you know how to put that in your calculator. So as I take a look at my calculator and I want to put that in, I guess I don't need all of those calculators. How many did I open? All right, so we're going to type it in as we are looking at this as 75 times, you don't need the parentheses, you can just put 0.085. And on my calculator, it's the X to the Y button. Some of your calculators, it's going to be this button, X to the Y or Y to the X. And it says, notice up here, you see it as a caret. What do you want to raise it to? And I'm going to say 16. And I hit equal. And so as I am taking a look at that, I get how many inches should it be? About 5.5, right? 5.5 if I'm looking at this, right? So did I put that in the right spot? The bridge is 6 inches long when we think about our axis, right? Our length in inches, okay? So as we are taking a look at that, if it's 16 inches long, it really only holds about 5.5, or since we're talking about pennies, we might say 5 pennies, right? We're not going to round it up. Could someone have told me 6 pennies? Yes, I would take that answer also. It now says, well, what if it's a 3-inch bridge? Do you think 3 inches is holding more than the 4-inch? Looking at your graph from before? We would think so. Let's put that in our equation. Y equals 75. 0.85. You're going to raise it to the 3. This is because x is equal to 3. So remember, our 4 held 42. We should have more than 42. Someone want to tell me what they got when they put it in? Camden, what did you get?
I got 46.
46. Does that sound about right to everyone? 46 pennies. So it should hold more. So when you're doing the problems, this is the key thing. I'm going to give you an equation. You do sometimes need to use your calculator. I am going to have you, we're going to continue with the I10 in your notes. We will be doing page 48, 49, 20 as we look at this. So on page 20, as we take a look, again, those same I10 statements that we've been talking about the last few days. So if I drive home at 30 miles an hour and I get home in I will get home in half the time as if I were to drive 60 miles an hour. Is this relationship linear? So when I take a look at that, I'm trying to think. as I look at this, is it going to be linear? And that's what we are going to look at today. So I don't need you to answer, yes, I think it is, or no, I think it's not. We're going to take a look at that. Key thing, right, when you're talking about distance and speed, remember distance is equal to your speed times time. And this is distance over here. So if you want to write that in, that's kind of something to think about. Distance is always equal to speed and time. So this miles per hour, that's our speed. So if I want to find my speed, one of the things I often have to do is take distance, if you're writing this out, and I'm going to divide distance by time. Right? Jason, did you write that? Right on the bottom of that page of notes. The tour will ride from Philadelphia, Pennsylvania along the Atlantic coastline to Williamsburg, Virginia. When the tour is over, the riders will take the bus from Williamsburg back to Philadelphia, a distance of about 300 miles. Everyone's in a hurry to get home, so the bus driver is tempted to drive fast. Should the driver speed to get home quickly? Yes, no, why? So put down your answer, what you think. Okay? No judgment here. You just write down what you think. Yes, no, why? Write that in your notes. So in this problem, we're going to study the relationship between the average speed of the bus and the time it takes to reach Philadelphia. You'll get to see how much difference traveling time and distance faster really makes. Sometimes when you think you're in a hurry, you need to get somewhere. So again, with those calculators, we are finding if our average speed is 30, we want to know the time. Now, we know that distance, in our case, was equal to 300. And we are going to be dividing that by your speed. Speed is X. My trip time is Y. So 300 divided by 30, no problem, right? Don't even need your calculator for that. I should have. It's going to take me 10 hours. Does that make sense, everyone? On your calculator, please take 300 divided by 40. Alyssa, you got 7.5. Stephen, we're taking 300 divided by 50. What'd you end up with? 6. 300 divided by 6, if I'm looking at it. Abby, what'd you have? 5 hours, right? So if I go 70 miles an hour, what am I looking at, Camden? How many hours? About 4.3. So it says looking at the data and what happened at our trip time. As the speed increases, is it linear or non-linear? Are we subtracting the same thing each time? Definitely not. Please write this as you are taking a look. In that box, right, it looks non-linear because the trip time is increasing by smaller amounts each time we go 10 miles an hour faster, right? So by going 10 miles an hour faster, it is definitely changing my trip from going 30, right, in a snowstorm blizzard. Right now, a dust storm in North Dakota. I don't know if you guys saw on the page, North Dakota, they showed that you couldn't see the speed because of the wind blowing the dust. But in the winter, a snowstorm, you're driving much slower than if you can make it in 5 hours, right? This will give us a curved shape to our graph. So at the bottom of page 21, as you finish writing this, we are going to be taking a look at the bottom of page 21 at modeling this. Please put the word speed and miles per hour on your x-axis on that graph on the bottom of this page. Please put the time in hours on your y-axis. Time in hours, speed. We're going to have our speeds because I'm going to go up by 10 because they said each time we were changing by 10. So on that bottom of that page, put speed 10 on your graph, put hours going up by 1. So speed on the bottom and on the top of page 21. what I should now see is my curved graph, right? I'm going to see, as I look at this, at 30 we had 10, and I'm going to see each of these. So it says, write an equation that models the relationship of speed and time. So if we are looking at this, I just want you to know there's a few different equations you could have had. The first one, we could say that our speed was equal to, or S equals 300 divided by time. That's one equation. And if you like to do divided by 2, you could do it this way. If I'm finding time, T, that would be 300 divided by, what did we do each time? We divided it by our speed, S. Or we could say that time multiplied by our speed, T times S, has to equal 300. Anytime you divide by a variable, it's going to be nonlinear. Anytime you divide by a variable, it's going to be a little curve like this as you are looking at these. So at the top of the next page, as you are looking at page 22, the last of our notes for today, says the bus driver figured out that if he increased, right? So if he increased the speed from 40 to 45 per hour, the time of the trip was shortened from 7.5 to 6 2/3, saving about 50 minutes. He reasoned that the increased average speed from 45 to 50 miles per hour would cut another 50 minutes off the trip. Increasing his average speed from 50 to 55 per hour would cut it another 50 minutes. Do you agree? Should it always be that same? No, we just already said it was nonlinear, right? So if we are thinking about what he said, it should be definitely no. It's not a linear pattern. Linear patterns would have been, yep, it's always going to go cut 50 minutes off. Ours cuts less and less, right? Says, how is your answer for part A illustrated, shown in the graph of our data? And you should be able to write this is that it was a curved line. It was not straight, so it was not constant subtraction. On page 22, right below our notes, when you look at a table of data, explain how you determine if it's linear. So think about that table. How did we determine if the table was linear? So right below on page 22, put number 1 and explain in your own words. How do I know a table is linear? What are you looking for? Then put number 2. When you look at a graph, explain how you determine if it's linear or if it's a curve. How do you determine that? Okay? So put that right? So if I was answering this question, if I look at it, it has to be a constant slope. I might say even better than constant slope if I'm looking at that. It has to show constant addition or subtraction in the table, right? For the y value. So the y has to have a constant adding or subtracting of the same number. Whereas if I'm taking a look at a graph, when I ask you this question on your test next week, how do you know on a graph? Either they make a straight line or they make a curve. That's pretty much all you have to tell me. Why do you think this is linear? Because it makes a straight line. Why do you think it's not linear? Because it makes a curve. So tonight's homework you are finishing. Yesterday we did 47 and 48. This is page 49, which is still 9, and this is page 50. So when you take a look at question number 9 on that page, it says this time the two numbers that you're picking, the length and the width, so the perimeter, so when you go to draw your graph, X, Y, right? X, Y. X is always down here. Make sure you put width L must equal 35. You can put a ton of numbers, right, that add to 35. That means their perimeter would be 70. So they use 15 and 20. Can we switch those two around? Yes. I don't know what numbers you're going to use. If you use really small numbers like 1, 2, 3, 4, 5, and then you have 15, you got to make this go up to 15, right? What if you pick numbers like you spread it out and you have this going up to 35? Well, then yours are going to be different, right? So you're going to set your own scale as you do this problem. Over here, it's telling you that the length times the width must be 16. These are the lengths. I give you the length. So you have to divide 16 by that number to find the width, right? Okay, so it says you're going to have some fractions or decimals in your table as you take a look at that.